Hello and welcome to all. In this lecture, we want to discuss the various application related to the push down automata. We want to discuss about deterministic and non-deterministic push down automata, and finally, we want to discuss about closure properties of the push down automata. So first of all, we will see the parsing and PDA. So for performing syntax analysis or parsing, the CFG is created. Whenever we want to perform syntax analysis or parsing, then we will require CFG. CFG is created for recognizing the programming constraint. Okay. So the CFG, that is context free grammar, then it can be handled using push down automata. Okay. Parsing is the process by which input source is broken into the words or tokens. Okay, into the words. Parsing is a technique with the help of that we can divide the input source into number of words. There are two types of parsing. One is bottom up parsing and second one is top down parsing. In case of top down parser, it starts from top with the start symbol and derive a string using the panel tree. Okay, it will going to derive the string. Now in case of bottom up parser, it start down the bottom with string and come to the start symbol using the parse tree. Means it's a reverse. In case of bottom up parser, we need to start with bottom of the string and we need to come up to the start symbol of the parse tree. In case of top down parsing, we need to start with the starting symbol and we need to come to the bottom or last symbol of the parse tree. Now bottom up parsing, parse tree is constructed from leaves to the root. Here one more definition, from leaves node to the root node. Here we are going to construct the bottom of parse tree. Now in case of top down parsing, parse tree can be constructed from root node to the expanded up to the leaves, and parse tree is built from top to bottom. PDA is used to model the CFG used for parsing the given input string. Now difference between top down parsing and bottom up parsing. In case of top down parsing, parse tree can be built from root to the leaf. In case of bottom up parser, parse tree can be built from leaf to the root. Top down parsing is simple to implement as compared to bottom up parsing, because bottom up parsing is complex to implement. Top down parsing technique is less efficient parsing technique. Bottom up parsing technique is more efficient as compared to the top down parsing. Top down parsing is applicable to small class language problem. Here bottom up parsing is applicable to broad class language problem. Okay. And in case of top down parsing, various techniques such as recursive descent parser or predictive parser can be used. In case of bottom up parser, shift reduce parser or LR parser is used. Now closure properties of the PDA. So PDA is closed under union operation. PDA is closed under the concatenation operation, and PDA is closed under the intersection for regular language. So these are the closure properties of the PDA. So how to prove it? Already we have discussed in case of the CFG. So same way we can prove that the PDA is closed under union, PDA is closed under concatenation, as well as closed under the intersection. Now deterministic and non-deterministic PDA. So DPDA, deterministic PDA, which is defined by using total 7 tuple m is equal to capital Q summation, after that stack symbol delta Q0 F and Z0, where capital Q indicates that the finite non-empty set of state or total number of states are required to design the PDA. Summation set of input alphabet, tau indicate that the stack symbol, delta is the transition function, mapping function, next state function. In case of this DPDA, which deterministic PDA, delta is nothing but current state into current input alphabet, let us say A, or current input alphabet, summation into topmost symbol of the stack. It will be in the next state, means it will be in the only one state, deterministic state, and after that it will decide the after deciding the push, pop or no operation of the stack. So here in case of DPDA we will get the single state as a transition. Okay, Q0 is the initial state, F is the final state, and Z0 is the initial stack symbol. Now in case of here DPDA is represented using 7 tuple, and there is a single transition on a given input alphabet, and here all these tuples are defined. Q is finite non-empty set of state, summation set of input alphabet, to indicate that set of stack alphabet. Q0 is start or initial state, F is the set of final state or final states. There may be the case we may have more than one final state. Z0 is initial or start state of the stack, and delta is the transition function. Here you can see current state into current input alphabet. If you don't have the current input alphabet, then we are going to consider epsilon as the current input alphabet. By considering topmost symbol of the stack, we are in the next state, and there is only one state as output, and stack operation, push pop or no operation. In case of non-deterministic push down automata, there can be more than one possible transition on a given input alphabet. So it is possible that we may have more than one transition. Okay, here it will be capital Q, finite non-empty set of states, summation set of input alphabet. Again, it is defined by using 7 tuple. Means that NPDA. NPDA is defined by using 7 tuple, and tau is set of stack alphabet. Q0 is start state or initial state of the NPDA. PDA, non-deterministic push down automata. F is the set of final state. Z0 is initial stack symbol, and delta is transition mapping or next state function. Here delta is different. Current state into current input alphabet by considering epsilon. If we don't have the current input alphabet, into topmost symbol we may have 2 raised to q number of state. Here it will change 2 raised to q number of state, and stack operation. After taking the push pop or no operation, we will be in the next state. So this is the NPDA. So I'll stop here. Thank you.